Hi everybody, this is part 2 of my previous tutorial. It's about separation of variables, and last time we learned how to get to the general equation. Essentially, we started out here and then we put it into a form of y equals xxt, like capital X, simple x, capital T, simple t, and then we found the derivative in terms of t, the derivative, double derivative in terms of x, and subbed them back into the original equation, and then isolated, found lambda. Feel free to check it out if you haven't so far. It should definitely help clarify how I got to the general equation. But now we're going to use these boundary and initial conditions in order to solve the problem. So for starters, what we're going to have to do is this. We are going to have to put in the first boundary condition, which is y x equals 0 comma t equals 0. And then, so from that, you can tell 0 equals a times h plus it plus cj e to negative c squared lambda squared. And you get this from plugging in 0 for x pretty much. And then, but from this, you can tell three things. You can tell either AH equals 0, AI equals 0, or CJ equals 0. Now from these three, we have a choice as to which ones we can choose. I personally chose to use A equals C equals 0. And I'll explain why. I chose A equals C equals 0 because if I chose J equals 0, then this all gets crossed out, and for the lambda does not equal 0 term. And if I chose, same with choosing B equals H equals I equals 0. So essentially when you choose A equals C equals 0, you end up getting left with, you get to keep the lambda equals 0 and lambda does not equal 0 terms, so you get more of a robust solution. So after plugging this in, I get y x comma t equals bx h plus it plus d sine x times j e negative c squared lambda squared t. And from this, you can notice b is a constant, and h is a constant, and then I is a constant. So d and j are also constants. So b times h would also be a constant, for example. And so, to make this a little simpler, I'm going to write down more constants, but I'm going to change this to x equals k plus mt plus n sine lambda x e to the negative c squared lambda squared t, where I pretty much just made b times h equal to k. So here I'll just write it on the side. So bh equals k, bi equals m, and dj equals n. Just for clarification. And then from here, what we can do next is find the derivative of this in terms of x. And the reason why we're finding the derivative is because the second boundary condition is in a derivative form, so like a dx form, so we just have to pretty much work with it. So yeah. So basically over here we got k plus mt because this x is gone, and then n lambda cos lambda x e to negative c squared lambda squared t, and we can treat this stuff over here as like a constant in this case, since because it's dx y, and then so it has nothing to do with the t, so you can just ignore the t terms, just keep it and only work with the x. Okay, now moving on from here, you can go like this: k equals m equals 0, right? Oh, well, first of all, I should probably plug in my boundary conditions. Sorry, I got a little carried away there. Having too much fun, I guess. Okay. dxy, and then x equals L, comma t equals 0, right? So then we get 0 equals k plus mt plus n lambda cos lambda L times e to negative c squared lambda squared t. So again, we just plug in x, or L for x, and then from this we can get two things. First of all, k equals m equals 0. Just because it's like, because of the way it works, pretty much right side or left side 0, yeah. And next, what I should do is write n lambda cos lambda L equals 0, right? And from this, you can go like cos lambda L equals 0, or n equals 0. Now what we want here is cos lambda L to be equal to 0, because otherwise we just get a trivial solution where everything equals 0, and that's not what we want, because it's not good enough. So for our situation, but essentially, since this is cosine, you go 2n plus 1 times pi over 2 is equal to lambda L. When n equals 1, comma 2, comma dot dot dot. You can verify this by plugging in 1, you get 3 pi over 2. Plug in 2, you get 5 pi over 2. And those are all, when you put that into cos, it works out. So then, therefore, lambda, first of all, is just this stuff. Over L, so yeah. So just isolate for lambda. And then next, we can write this out. So first of all, I'm going to write it out in this format. yxt is the sum from n equals 1 to infinity of n to the power of n. Not n to the power of n, simple n, pretty much denoting which n. But anyways, sine 2n plus 1 times pi over 2 times x over L e to the power of negative c squared, and then 2n plus 1 times pi over 2 squared times t. Now, all I did really to get from what I did before to here was I put the n here to factor in for all the different n values. And over here, instead of writing lambda, I wrote the other form for lambda, what I got, and I just pretty much plugged it in. And carrying on, now we can finally stick in our initial conditions. So first of all, y x comma 0, or I can write x comma t equals 0, I guess, to stay consistent, equals f of x. Now from this, you can tell that f of x equals sigma n equals 1 to infinity of n sine 2n plus 1 pi over 2 times x over L. And then since t equals 0, the e term cancels out, and then yeah, it essentially becomes 1 because it's e to the power of 0. And yeah, this is one of your initial conditions, I guess. And then next initial condition, first things first, actually, I'm gonna get the dty x comma t. The derivative, now this time, before it was a derivative in terms of x, this time it's a derivative in terms of t, so pretty similar. All you do is you do it for t instead of x, pretty much. So essentially what we have to do here now is write sigma n equals 1 to infinity of nn sine 2n plus 1 times pi x over 2l times e to the power of negative c squared 2n plus 1 times pi over two L. Hold on. Let me write this a little neater. Squared t, and you take this and you divide it all by negative c squared, and then 2n plus 1 squared, no, times n over 2l squared. So over here, this might be a little tricky to see, but this is basically just saying e to the power of, I guess, e to the power of, the usual term, the lambda squared, c squared lambda squared t. So, yeah. So now, from this, when we find the derivative so our next boundary condition, first of all, or initial condition I should say, is dty of x comma t equals 0 equals gx. Or dy I guess you should say, but essentially gx then ends up equaling from n equals 1 to infinity, negative n to the power of n times sine 2n plus 1 times pi times x over 2 over L. So basically lambda divided by c squared times 2n plus 1 pi over 2L squared, again, lambda squared. And the reason why we get this is because if you put in 0 to this term, all the e gets canceled out, and so you're left with basically everything but the e. And yeah. And there you go, everybody. I hope this video helped explain this concept, and I wish you all the best.